Alright, we're doing lesson 18 from your math workbook today. This one talks about factors, unit conversions, area model, and fractions. Alright, so let's get started. We're going to do number 1. Find all the factors of 28. So 28 is the number we're working with to find all the factors. So what numbers can go into, when we're thinking about multiplication, 28 evenly without going over? So the first thing I can do is start with 1 and 28, because 1 times 28 is going to be 28. Those are always the easiest. It's going to be 1 and the number itself are always going to be factors. So then let's go to the next number, which would be 2. I can already tell you, yes, 2 will go into 28 because 28 is an even number. So 2 times what number is 28? And that's going to be 14. Okay. The next number would be 3 that I would try, but I can tell you if I skip count by 3, 3, 6, 9, 12, 15, 18, 21, 24, 27, and then 30. That passes 28, so then 3 is not a factor of 28. So then let's go ahead and skip 3, and now we're going to try the number 4. So 4 is a factor of 28, and let's prove it with skip counting. 4, 8, 12, 16, 20, 24, and 28. Okay, so we landed on 28, so it's a factor. So now let's see how many times. 1, 2, 3, 4, 5, 6, 7. So 4 times 7 is 28. The next number we would try is 5, but I already know from my factor rules that in order for 5 to be a factor of a number, it has to end in the number 0 or 5. So 28 does not end in 0 or 5, so 5 is not a factor. So now let's try 6. I'm going to skip count by 6s to see if 6 can go into 28 evenly. So 6, 12, 18, 24, and then 30. So again, I passed 28, so 6 would not be a multiple of, a factor, sorry, of 28. So 5 was not, 6 was not a factor, so then the next number we would try is the number 7. And because we already have that here, we're done. So all the factors of 28 are 1, 2, 4, 7, 14, and 28. All right, let's move on to number 2. So number 2 states, Sergio ate 10 pounds of fish over the course of 1 year. So 10 pounds Sergio ate in 1 year. Okay, 3 of those 10 were salmon. So we can go ahead and write that here. 3 pounds were salmon. And it says the rest is that key word, of the fish was cod. So rest tells me what's left over. That's subtraction. So I can go ahead and subtract this. 10 minus 3 is 7 pounds are left, and that is going to be cod. So 7 pounds of the total 10 that he ate in 1 year was cod. How many ounces of the cod did Sergio eat in 1 year? So they want to know the total, not in pounds, but in ounces. So we have our total right now in pounds, so we have to do some conversions here. So I know that 16 ounces is equal to 1 pound. Okay, so now I have to multiply 16 times my total in pounds, which is 7, to get a total in ounces. So I'm going to go ahead and solve that with the standard algorithm down here. 7 times 6 is 42. 7 times 1 is 7, plus 4 more is 11. So I can say that the total number, total of ounces of cod that Sergio ate is 112 ounces. So that's the number, that's your answer for number 2. All right, let's do number 3 now. Find the area of a rectangle that has a width of 20 inches and a length of 14. So 20 inches and 14 inches, and we're finding the area. So go ahead and draw your rectangle. We want to know the area. 20 inches here and 14 here. So I'm just solving this mathematically using multiplication. We know that to find the area of a rectangular shape, it's length times width. So we need to find out 20 times 14. And because this is 2 by 2 multiplication, I'm going to do the area model as my strategy. 20 on this side, and then 14, there's a 10 that lives inside of that, and 4 ones. So now I can multiply to find the area inside each part, and then add that up together. Alright, 20 times 10 is 200. 20 times 4 is 80. Now I'm going to add 200 plus 80, and I'm going to get 280. So this number equals my area. Area equals 280 square inches. Alright, let's move on to number 4. Joseph has 1/8 pounds of sunflower seeds. Leo has 5/8 pounds of sunflower seeds. So they both have sunflower seeds, which makes it easy for us. And it's represented in fractions, how much they have. They both have the same denominator, so the same unit, which makes it easy too. Now let's keep reading. What is the total amount of sunflower seeds the two boys have? So total. That tells me they're wanting us to add. And with fractions, we've been learning that in order to add and subtract, we have to have the same denominator, the same unit of fractions. So we have eighths here in both fractions, so we can just add straight across. My denominator will not change. I'm adding 1 plus 5, that's 6. So the total amount of sunflower seeds they have of pounds is 6/8. Alright, last one, number 5. Use an X to mark each data point in the data set on the line plot. So this is going to look really familiar. They're giving us a bunch of fractions that they want us to plot on a number line. So I'm going to go ahead and do that here. I'm going to really look at my fractions and ask myself, do I have any fractions that are greater than 1 or greater than a whole? 6/10, nope. 1/2, 3/10, 1/5, and 5/10. Nope, I don't have anything greater than a 1, so I can label my number line 0 to 1. Okay, and a half is really easy to place, but I'm going to hold off on that because I want to make sure I accurately plot the other fractional units on my number line. Okay, so I have tenths here and fifths here. So I'm going to start with the fraction 1/5. Okay, so I'm going to break up my number line into fifths. 1/5, 2/5, 3/5, 4/5, and then the whole would be where the 5/5 would go. Okay, so 1/5 is right here, so we can mark that one off. Now, I don't have any more fifths, but I do have tenths. Okay, and I know that I can easily change my fifths into now tenths. So watch what I'm going to do. I'm going to put all of these, I'm going to split all of these in half to represent tenths now. Now I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 parts. So now I can go and plot my fractions on my number line. So let's start with 6/10. 1, 2, 3, 4, 5, 6. 6/10 would go here. Okay, mark that one off. Let's do 3/10 now. 1, 2, 3. So this would be 3/10. Mark that one off. Let's do 5/10. 1, 2, 3, 4, 5/10 would be here. Okay, and 1/2. What I know about 5/10 is that 5/10 represents half, And so it's equivalent to 1/2. So I'm going to place my 1/2 right about here on the same spot. Okay, so we have 1/5 plotted, 1/2 and 5/10 plotted. We have 6/10 plotted also. And we're done.